Welcome to Bravel Institute. Today we are discussing about cost proportional hazard. What is the cost proportional hazard? How to solve our problems? For that, I will consider small mortality investigation to understand this model, how to perform this model. So there is a small example. I am selecting my village. This is my village. In my village, 100 people are staying. In my village, 100 people are staying. I am doing mortality investigation. So these are the people staying in my village. 100 people are there. I just is an example. So I initially done one survey. What is to understand their mortality. So in my survey, I understood all people are living very happily and healthy people. So I thought is a constant hazard. I thought this is hazard rate is constant. Hazard rate is constant. So I thought it's a constant hazard and these people will live up to 90 years. If there is an accident only, there is a death, maybe it is an accident, due to accident only. So I thought people will live 90 years because all are very healthy people. In my survey, I am not asked any other conditions. So I thought these people will live up to 90 years. But after some years, 1 or 2 years, I analyzed again this village, whether this any changes happened or not. So after some time, I analyzed this village. I understood this person is died at the age of 40. This person is died at the age of 50. This person is died at the age of 60. So what is the reason? These people are, in my concept, those people has to live up to 90 years. But here, these people died at the age of 40, 50 and 60. So this person is died because of he was a heavy smoker. So due to cancer, this person is died. He is an alcoholic. Due to that, this person is died very early. He has some surgery, health issue. Due to that, this person is died at the age 60. So what I understood, initially I have done survey, I got a constant hazard rate, but now these people are different. Some other factors is affecting their mortality. Initially I not considered these factors. So now I'm looking different factors is affecting their mortality. So I decided to divide these people into different groups. What is their nature? What is their character? I'm going to divide these people. So there is a heterogeneity in nature, heterogeneity in character. Different people have different character. Is a smoker, this person is not a smoker, non-smoker, non-alcoholic, may live 90 years. So like that different character, I'm going to divide these people into different groups. So initially I taken male and female. I'm going to divide these 100 people into different groups. First in their age, I make a one aged people and their smoking behavior, whether it is a heavy smoker, light smoker or non-smoker. It is a female smoker, it is a male smoker. And alcoholic. And their salary, their living condition. Some people have good salary, they are living in very good environment. Here and their occupation. I dividing these people into different groups. So these groups, everybody have same character. So we can say it's a homogeneous group. This female and alcoholic means this group have same behavior. So we can say it is a homogeneous group. So these all factors is affecting their mortality. So initially my constant hazard rate is equal to, depend on time, it is a lambda 0 t. Initially I make a my hazard rate is depend only in the time, and I make a one equation, hazard rate is constant for everyone. But now I understood these are the factors is affecting their hazard rate. So these factors I call covariates. These all the factors, what are the factors is affecting their mortality, I call it is a covariates. So I understood hazard rate is affected by covariates. Covariates are representing Zi. Hazard rate is affected by covariates is representing Zi. Exponential beta I into Zi raised to t. This is my equation. So David Koch is 1972. He understood these are the some factors is affecting their hazard rate, their mortality. So he make these all factors as a covariates and make a equation exponential beta I into Zi raised to t. Zi is the covariates and beta I is the regression parameter. I will explain what is the beta I. Beta I is equal to regression parameter. So these people have some effects on mortality. A smoker will affect 0.001, will increase the mortality by the value 0.001. Maybe in their alcoholic person 0.002. So this much value will increase their mortality. Sometimes they are taking medicine. Then hazard rate, this regression parameter may be minus 0.01. So regression value will give in the question. So there is each term, each factor have a one regression value. What this value is affecting their hazard rate. If this regression value is positive, what will be here? Exponential factor will be greater than 1. That means their hazard rate will be increased. Regression value is alcoholic, the regression value is 0.02. So increase here, beta is equal to 0.002. So increase their hazard rate. This is positive, beta is positive, their hazard rate automatically increase from baseline hazard. If it is a minus, negative 0.01, then what will happen? Their hazard rate will decrease. So this hazard rate is depend on covariates and this regression value. Second is covariates. How to take a value of covariates? So Z is a covariates. These all factors is a covariates. How to take a value? If it is a smoker and non-smoker, how to take a value? We don't know. But if it is a age, I can take a age. If it's a age, I have a value. 50 or 60 or 70, his value is there. If it is a weight also one of the factor. If a obese person means there is a chance of heart attack, some other disease. So weight also one of the factor. If weight, I can say it is a 70 kg. What are the weight we can say like that? If it is height also you can say 150 centimeter, like that we can express. So Zi value will be like that. But if it is female or male, female or male, then how to give zi value? Zi value has to give zi, we have to select a zi as a dummy variable, is a 0 or 1, give 0 or 1. This 0 or 1 depend on the regression value. If female have no regression value, then we can take as a baseline group 0. Male have regression value, we can take as a 1. If female have a regression value, we have to take a 1. If male have no regression value, we have to take a 0. So this is a dummy variable called dummy variable. We have to take a 1 or 0. In solving the problem, we will understand what is the 1 and 0. And next is one more term is there. It is a t. This is a t. It's a transpose of the vector. It is not a lifetime. It is a transpose of the vector. So this is our equation lambda. The hazard rate is depend on lambda is depend on time and covariates zi. So lambda 0 t exponential beta I and zi. If these all factors is not there, then what will be their hazard rate? There is no factors is affecting their mortality. So these all covariance factor is 0. Zi is equal to 0. So this value, what will happen? This values become 1. Exponentially depend on. So exponential 0 is equal to 1. So lambda t zi is equal to lambda 0 t. So this lambda 0 t is called baseline hazard. Baseline hazard means all the covariates is 0. There is no factor is affecting their mortality. All covariates, these all values become 0. These factors is not affecting their mortality. Then we can say hazard rate is equal to baseline hazard. Hazard rate is equal to baseline hazard. We'll solve one problem. We'll understand what is the how to apply this equation. For example, age is equal to 60. Age is equal to 60 and their beta I regression parameter is 0.01. 0.01. Height is equal to 150 centimeter and the regression parameter is 0.02. No need 0.02. 0.002. This person is taking medicine 40 mg every day. This is regression parameter minus 0.02. So in our question is explained about one character of one person. So that person age is 60 and age is depend on regression value is 0.01 and height is 150, their value is 0.002. He is using medicine or drugs in every day. He is taking 40 mg of medicine. So value is minus 0.02. This minus value will be decrease their hazard rate because it is regression parameter is negative. How to place one is into our equation? So this is our equation. Lambda t zi is equal to lambda 0 t exponential beta I into zi raised to t. So lambda t zi equal to lambda 0 t exponential beta I and zi. Beta I is equal to 0.01 into zi is equal to age 60. Have to take a value. With the age, we have to take a value plus. Height is 0.02. 0.002 into 150. Height is 0.002 into 150. Minus. This is 0.02 into 40. So this is our equation. We substituted beta I is equal to 0.01. Z I is a first covariate we considered as a age is 60. So 0.01 is multiplying to 60. And the second height is 150. Regression parameter 0.02. Third is minus 0.02. And its value is 40. So we substituted these all covariates and their values in the equation. So what will be here? It is zt exponential 0.6 plus 0.3 minus 0.8. So this is the value. What will be value? 0t exponential 0.1. Their age is multiplied with 0.6. If these two factor is not there, it is affect mortality by 0.6. And here 0.3. He is taking medicine every day. This mortality rate is reduced 0.8. So 0.9 minus 0.8 is equal to 0.1. This value lambda 0 t exponential 0.1 will be 1.1. So initially their hazard rate lambda t z I is equal to lambda 0 t baseline hazard, and due to this combination their hazard rate is increased 1.1 times. If initially for example initially it's a for 0.5, if it is a 0.5, then lambda 0 t baseline hazard initially we declared it is a 0.5, then what is happened now it is increased to 0.55. So hazard rate is increased in this age, height and medicine. In this combination hazard rate increased to 1.1. So you understood how to substitute these values into equation. Now we will explain why it is called proportional hazard. What is the reason why it is called as a proportional hazard? We can compare each individual. We can compare female alcoholic person. What is their mortality rate of female alcoholic person with a male alcoholic person? We can compare what are the rate. Female smoker we can compare with a male smoker. We can compare this all the individual who is the hazard rate more or less. That is the reason we can call it is a proportional hazard. So if lambda t z1, this is now we taken one covariates. Z1 is equal to lambda 0 t and exponential beta I z1 raised to t. This is our first equation. This is we taken z1 is a first covariates. This we can compare with lambda t comma z2. In that z2 is a second covariates lambda 0 t exponential beta I z2 raised to t. So these two factors, these two covariates, how is affecting the mortality rate? What is their mortality rate? Whether female smoker or mortality rate is higher for male smoker. whether male have alcoholic person is higher the mortality rate for female alcoholic person. So we can compare with these factors, these covariates, we can compare with this their mortality rate by this cost proportional hazard divided by second covariates. So because of this, we can say it is a proportional hazard. We can say because of comparison with the other person, a comparison with any other parameters. We can take a covariates as a different things. Then we can compare each individual to other values. So because of comparison, we can say this hazard rate, this cost proportional hazard, this is a cost proportional hazard. We are comparing with the other one. So we can say it is a cost proportional hazard. This comparison will understand in this solving the problem. One more problem I'll solve, then I will explain how to compare this hazard rate. Another thing, if you are comparing with the hazard rate is comparing with the Z1 and Z2, then lambda 0t divided by lambda 0t. This term is constant in both. In both covariates, we take both covariates Z1 and Z2. This lambda 0t is common. This value is common in both. We can remove this value because it is the same for both. If you take a Z2 or Z1, lambda 0t is constant. So we are going to remove this value. We can remove this value. So hazard rate is depend on exponential factor of regression value and covariates. We removed the baseline hazard. That is important. We removed this baseline hazard from my equation. So due to that, we can say cost proportional hazard model is a semi-parametric model because baseline hazard is not affecting their mortality. We are comparing with two individuals, then baseline hazard is not affecting. What is the shape of baseline hazard? That shape is not affecting the comparison because we cancelled. The term is removed. So that is the reason we can say cost proportional hazard is a semi-parametric model. This semi-parametric and fully parametric, there is need some other class. We'll explain what is a fully parametric. What is a fully parametric? Why it is called semi-parametric? Fully parametric model means we have a one distribution. We are doing the investigation. We got some value. We have done some investigation in village, 100 people in the village. So we got some values. We have to substitute. We have to fit this value in one parametric distribution. What are the parametric distributions are there? Exponential and Weibull distribution and Gombert's and Meekham. So these are the distributions available. Log logistic, one more distributions are there. These four distribution only available in our books to study. So these are the distribution available. So what are the values by observation? What are the value we received from the our mortality investigation? This value has to substitute in the exponential distribution. So in exponential distribution, if you substitute the value, it is a constant hazard. We getting the constant hazard. If it is a variable, it will be a decreasing hazard. So different model have a different behavior. That shape also different. Variable maybe it is like that. It is decreasing. So their shape is different. Each model have their shape. This is constant hazard, this is decreasing hazard, so shape is different. So what are the values getting in the investigation? We have to fit in the exponential or Gombert's, Weibull, wherever. And one more thing, we have to choose the correct parametric distribution. When you are fitting the data, what are the data is received from mortality investigation, this data is fitting to which parametric distribution. Selection of this parametric distribution is really important. Otherwise what will happen, it will be a wrong shape. If it is a decreasing hazard, we have to select a variable. If you select a exponential, it will be a wrong shape. So selection of the parametric distribution is important in the fully parametric model. We have to take a value and fit with one parametric distribution. But in the semi-parametric, we no need to fit with any model. We are comparing with two individuals. So this baseline hazard, what is the shape of baseline hazard is not affecting their hazard rate. Whenever we compare in the hazard rate, this baseline hazard, the shape of the baseline hazard is not a matter. That is why it is called semi-parametric model. So we'll solve one more problem, then we'll understand how to calculate the hazard rate, how to apply this hazard rate. So in this chapter, I explained what is the cost proportional hazard rate lambda t zi is equal to baseline hazard and regression parameter and covariates. Only these three factors only studying this model. And this beta I will available in our question, and zi also will available in question. We have to select what are the zi's. Lambda 0t, we no need to calculate lambda 0t. In any other questions, we no need to calculate lambda 0t. Our questions always will be comparison, which is better. This hazard rate is more than this hazard rate, or this hazard rate, whether this hazard rate is less than this hazard rate. So we are comparing with different covariates. So in our problem will be like that only, comparing with the different covariates. So I will explain one problem, we'll understand how to compare. In my city, there is a 3 hospital. In my city, 3 hospital. Hospital A and hospital B and hospital C. I want to do my heart surgery. I want to do my heart surgery in one of the hospital. In my city, there is a 3 hospital A, B, C. I want to do my heart surgery. So there is a regression values. There is a regression values is given for each hospital. This hospital there is no regression values. This hospital there is a regression values is minus 0.02 regression value, and hospital C 0.01. If I am a male, 0.03. Person want to do operation in 3 hospital, sometime male or female, whatever may be. This person want to do heart surgery in 3 hospital A, B, C. So their regression value is given. Initially, just looking in this question, we'll understand hospital B regression value is minus. So hazard rate will be less in hospital B. This is, you have to understood initial watching the problem, we should understand hazard rate is less. So female is there. We have female or male, but if it is male, regression parameter is 0.03. Hospital C regression parameter is 0.01. This is the our problem, and we will substitute what are the covariates is required. We will substitute to our equation. 3 hospital A and B, C and beta I. How to substitute? I will make one drawing. This is a female. This is a male. Here 3 hospital, A, B and C. So in male they given regression value 0.03. Given regression value 0.03. In hospital B, the regression value is 0.02 minus 0.02. And in hospital Z, regression value is 0.01. In both cases, we don't have any regression value. You can say it is a 0, 0. So what is my Zi? So I have to make my covariates. What are the covariates I have to take from this problem? So male or female, I have to take one Z1. How to take a Z1? If Z1 is equal to 1, it is a male, because there is a regression parameter is given here only. So I taken 1 and 0 for female. And Z2. Z2, there is a 3 hospital A, B, C. If n categories, there is a one equation. If n categories, we have to select n minus 1 covariates. Here A, B, C, 3 categories are there. Hospital A, B and C. So I have to take so n is equal to 3. For me, n is equal to 3. 3 categories are there. Then I am taking n minus 1. So I need n minus 1 is equal to 2. I need Z2 and Z3. I have to select 2 parameters, 2 covariates, Z2 and Z3. Because it is a dummy variable. Whenever is selecting dummy variable, check it how many categories are there. You have to take n minus 1 categories. So I taken Z2 and Z3. Wherever regression parameter is there, we have to give that value only. So 1 for hospital B, 0 for others. Here Z3 C, 1 for hospital C, 0 for others. So I selected covariates Z1, Z2, Z3. How I selected covariates? Male and female. I divided male and female. This is given male is 0.03. So I given female is 0. And 3 categories of hospital A, B, C. So B is equal to hospital B is equal to 1 and hospital C is equal to 1, because there is given regression value. Then what is my equation? Lambda T comma Zi. This is my equation. I have to substitute is equal to lambda 0 T exponential. This is my beta 1 and this is my beta 2 and beta 3. So Z1 is male and female. So my beta 1 is, this is my beta 1. Hospital B, this is my beta 2. This is my beta 3. So I taken beta 1 into Z1 plus beta 2 into Z2 plus beta 3 into Z3. So this is my equation. How to select a beta 1 and beta 2? Wherever this regression value is there, I have to select here. Beta 1 is here, male, Z1 is given and Z2 is given and Z3 is given. First question. So these terms we explained from the question, and they are asking what is the baseline hazard? What is the baseline hazard? Baseline hazard we know. What is the baseline hazard? Here is 0, is zi is equal to 1, here 1, here 0, 1 and 1. So zi values is 0, z1 is equal to 0, z1 is equal to 1, z2 is equal to 1 and z3 is equal to 1. So this is our problem. We have make one drawing for more understanding about the problems. In exam time we will not get a time to make a drawings and all. We have to make a equation and directly substitute the values. For more understanding I make a one drawing. So baseline hazard means all covariates values equal to 0. All covariates values equal to 0. That means z1 is equal to 0, z2 is equal to 0, z3 is equal to 0. So if you put z3, z2 and z1 value becomes 0, exponential 0 is equal to 1. Then what will get? Lambda t zi is equal to lambda 0 t. We will get only the baseline hazard. So what is the value? Z1 is equal to 0. So he is a female. He should be a female, because their covariates is 0. And if he is doing the hospital A, no covariates equal to 0. So female plus hospital A, that is our baseline hazard. Female, this z1 is equal to 0, so no covariates for female. This factor, that means if you are this female factor is not affecting the hazard rate more. This is 0. This factor is not affecting. Z1 is equal to 0. In hospital A, this covariates is equal to 0. So female is doing heart surgery in hospital A, that will be my baseline hazard. Female plus hospital A. So it will be lambda 0 t. Substitute here. Z1 is equal to 0, Z2 is equal to 0, Z3 is equal to 0. We got lambda 0 t. So this is my baseline hazard. Second question. Female in hospital B. Second, they are asking female plus hospital B. Female in hospital B. What is the hazard rate? What will happen in the hazard rate when female is doing heart surgery in hospital B? What will happen? Their hazard rate. I just remember here. Hospital, female is doing heart surgery in hospital B. What will happen? This is my equation. Female means z1 is equal to 0. Hospital B means z2 is equal to, this term is 0. Z2 is equal to minus 0.02. So my z is equal to lambda 0 t exponential female z1 is equal to 0. So beta 1 into 0 plus here hospital B is minus 0.02. Minus 0.02 into Z2 is equal to 1. Hospital B is a Z2 is a 1 in hospital B. So Z2 is equal to 1 for hospital B. Is my beta 2 is equal to, regression value is equal to minus 0.02. So what is this value? Lambda 0 t exponential minus 0.02. It will get lambda 0 t into exponential minus 0.02 is a 0.98 approximately. Approximately it is 0.98. So what happened my hazard rate? Because of this regression parameter is minus 0.02, this negative symbol, hazard rate is decreased. if my hazard rate was baseline hazard, if my hazard rate was baseline hazard means it is decreased from the baseline hazard. If lambda 0 t is multiplying 0.98, so it is decreased from the baseline hazard. How much percentage is decreased? 0.02 is decreased from the baseline hazard. Third question, male in hospital, male plus hospital C, male in hospital C. So male, there is a regression parameter is there. Hospital C also regression value is there. So how to calculate male plus hospital? We have to substitute Z1 male. So my equation lambda t zi is equal to lambda 0 t exponential Z1 is equal to 1, which is a male. Z1 is equal to 1 and regression value is 0.03. 0.03 into 1 plus hospital C is Z3. So we have to take this term. Z3 is equal to 1. Regression value is 0.01. 0.01 into 1. So what I got it? Lambda 0 t exponential 0.04. Exponential 0.04. This value is equal to lambda 0 t exponential 1.04. Exponential 0.4 is equal to, we will get into 1.04. So what happened? My hazard rate is increased. Initially, if it is a baseline hazard, now this combination male is going to hospital C. So what is my risk is increased? My mortality risk or my hazard rate is increased by 1.04. So if it is a hazard rate is 0.5 means in 0.5 into 1.04. So it is increased. My hazard rate is increased. So these are the three questions. Now in proportional hazard, they are comparing with this term is how, what is a baseline hazard, how much is increased, how much is increased from the baseline hazard. They are asking fourth question, what is the proportional of female plus hospital B, compare with baseline. If we compare with baseline, what is the, whether it is hazard rate increase or decrease. So fourth question is a comparison. Fourth question, they are comparing with the fourth question. Compare both baseline. We are comparing female plus hospital B, male plus hospital C is comparing with the baseline hazard. So how to compare? So baseline hazard is lambda t zi is equal to lambda 0 t. This is baseline hazard. Here female plus hospital A means there is no exponential factor, is like that. But if you compare with female plus hospital B, what is a female plus hospital B is like that. This is a female plus hospital B. So it is lambda t zi is equal to lambda 0 t into 0.98. I compared with female plus hospital B. So what is the value? This is equal to 1 divided by 0.98. We can remove this lambda 0 t. 1 divided by 0.98 is approximately 1.02. Approximately 1.02. So 2%. So we can say female in hospital B female in hospital B is compared with the baseline female in hospital A, 2% is less. Here 2% risk is less. We compare with baseline hazard, baseline female in hospital A will be 2% higher. 2% higher compared with the female in hospital B. So female is going to hospital B, their hazard rate, their percentage of hazard rate 2% is risk is less compared with the female in hospital A. Here if you go this combination, so Z2 is equal to 1. Here in this combination, 2% will be 2% will be decrease. Compare with this combination. If this combination compare with this female in hospital A, compare with the female in hospital A and female in hospital B, here 2% less because it is the regression parameter is minus 0.02. So here 2% is baseline hazard compared with the hospital B. If here 2% is higher than this combination. If you go further, baseline hazard with male and hospital C. So baseline hazard is lambda 0 t. Compare with male plus hospital C. What is the value? Male plus hospital C is lambda 0 t into 1.04. So this is equal to 1 divided by 1.04 is equal to 0.96. So compare with this combination, male plus hospital C, hazard rate is increased. So baseline hazard is 4% less. Compare with the hospital male and hospital C, this baseline hazard 4% is less. So their risk is increased. Male because this regression parameter is 0.03, here 0.01, and you have to multiply the baseline hazard into 1.04. So this value is approximately, there is some value will be there in further. So approximately 0.96, that means 4% is higher. Here itself will understand 4% is higher. Compare with the baseline and male plus hospital C, this combination will be 4% higher. That means here this combination will be 4% risk is higher. Compare with this combination. This is the first combination, baseline hazard. Compare with female and hospital A and male and hospital C. Here 4% of risk is higher. Or we can say baseline hazard is compared with the male C. Here 4% is less. So these are our problems. We have to compare with each individuals with different covariates. So that is the reason it is called as a proportional hazard. So I feel you understood about the cost proportional model and how to substitute the parameters beta I and zi and how to compare with the different individuals, male or female or some other case will give.